Happy Friday. Welcome to Tejano Virtual Event Happy Math Hour, our weekly interactive math reviews for Math 1314 and Math 1324, presented by Professors Yvette Chuca, Ruben Carrizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's event may be able to come and watch it. Thank you. So now at this time, please mute your mix for best sound experience, otherwise the feedback will interfere with the information we'll be sharing. We'll be sending the 1324 room link on the chat so that you may connect to your session if you are here for Math 1324. Mrs. Della or Mrs. Patricia will be sending individual messages to everyone to gather your student ID numbers to sign you in. And without further additional information, I'll pass it on to our presenters so that we may begin.
Good morning, everyone, and welcome again to our Friday Happy Math Hour. So what we'll do is, before we get started again, I'll give a couple of seconds for those of you who are here again for Math 1324. Please click on the link that's on your chat, and that will take you to the room for the 1324. The rest of you, go ahead and stay here for the Math 1314. So let us begin. So for today's session, we are going to cover synthetic division and complex numbers. So what is this synthetic division? Well, we've been reviewing in the past how to graph polynomials, okay? And it's very crucial for us to know the zeros of these polynomials, or the solutions, right? For instance, in this example here, they give us this cubic polynomial or function, and if we factor it out, we're able to see our zeros, right? We're able to see where it crosses the x-axis. Again, when we know that when the graph touches the graph and turns around, we consider that a double zero or a multiplicity of 2, okay? But sometimes it could be hard for us to find these zeros, yes? So division will help us find these polynomials, and so we can either factor them or find our solutions. So we're going to cover two forms of division. One is going to be long division, the other one is synthetic division. So let's start with the long division. So long division is arranging our terms where we do, like I call a little house. And the syntax for this, let me just talk about it, and then we'll see the example, okay? We're throwing out these terms out for you. Hopefully you're familiar with these terms, okay? This word dividend. Dividend means what we're going to divide into, and then our divisor is the one that's doing the dividing, right? It's kind of like the one that's outside our house. And our result is going to be our quotient, right? When we do the division, our answer or what's left over is our quotient, okay? Now, when we're doing this, we want to multiply our divisor to get the exact value that's part of our dividend in a certain order, right? And then we'll subtract. And again, this is just information, but the best way to see this is with an example. So let's go ahead and just get started with an example. Let's use long division to divide this polynomial. So my dividend is going to be 20x cubed minus 35x squared plus 23x minus 6. And my divisor is going to be 4x minus 3. Now, before we do the division, whenever we are looking at this polynomial, we got to make sure that our placement value for all of our terms is in the correct place. And the way we do that is we want to arrange our polynomial in descending order with our degree of our polynomial, the first term here. So our degree of our polynomial is 3. The degree means, again, that it's the highest exponent that all of our terms have, and they're in descending order. In this particular one, it's already in the order we want. It's in descending order. So we have the x cubed, the x squared, the x, and then we have our constant. Okay, so this is what's going to go inside my house. This is my dividend, and my divisor is going to be outside the house. Okay, so this is what I mean by house. Okay, so this is my divisor, 4x minus 3, and then I do a little house here, and I put my my dividend inside here. So we have 20x cubed minus 35x squared plus 23x minus 6. All right. So what I want to do is I want to multiply something to this 4x that is going to give me exactly these terms. But so let's get to it. So if I see here, what can I multiply to 4x to get a 20x cubed? Okay, so if you don't see it, we can also do the division of this, right? 20 divided by 4 is 5. X cubed divided by x is x squared, right? So if I would multiply a 5x squared to the 4x, that's going to give me this first term, the 20x cubed. So that's what I'll do first, okay? So this 5x squared goes on top here. And now I'm going to multiply. I'm going to multiply this 4x squared to this polynomial. Okay. So when I do that, 5x squared to the 4x, again, I get the 20x cubed. And then I have a 5x squared to the negative 3. So 5 times the negative 3 is a negative 15. And the x squared times just 1 is just the x squared. Okay. So this is my polynomial that I got from my multiplication. But again, from division, from long division, the next step is we have to subtract. Now we got to be careful because we are dealing with a polynomial. So that's why I put these blue parentheses out here, because I am dealing with a polynomial, not just a single number. So when I do the subtraction, I have to distribute this sign to both of these terms. Okay. So when I do that, okay, I'm going to get minus 20x cubed plus 15x squared. Again, a negative with a positive is a negative with a negative is a positive. Now I can add the polynomial. So here, 20x cubed minus 20x cubed is 0. Minus 35x squared plus 15x squared is minus 20x squared. And then I bring down my next term. Okay. So now I do it again. I do the process again. I say to myself, what do I need to multiply to 4x to get a negative 20x squared? Okay. So hopefully we see that it's just a negative 5x. A negative 5 times 4 gives me that negative 20. And x times x is going to give me that x squared. Again, I'm multiplying to a polynomial, so I'm multiplying the negative 5x to the 4x, giving me the negative 20x squared. A negative 5 times a negative 3 gives me a positive 15x, yes? Then I subtract. Again, I am dealing with a polynomial, so I have to distribute that sign. And it's going to give me positive 20x squared minus 15x. So then I add. Minus 20x squared plus 20x squared is 0, which is what I wanted. And then 20x minus 15x is 8x. And then I bring down my next term, my last term, minus 6. Then I repeat the process one more time. What can I multiply to 4x to get a positive 8x? Well, that would be 2. If I multiply 2 times 4x gives me the 8x. Then I have to multiply the 2 times the negative 3 gives me a negative 6, but then I'm doing a subtraction, so I have to distribute the sign. So negative times a positive gives me a negative 8x, and a negative times a negative is going to give me a positive 6. Okay, so when I add this, my remainder is 0. So this, whatever we have left over after we've used up all of our terms, whatever is left over here is my remainder. The values here that we got on top of my little house, this is what's called the quotient, right? Our answer from doing this division of these two polynomials. Okay? So this is how we do long division. Now, again, when we write answers, sometimes we're going to have a remainder, okay? And the way that WebAssign is going to want that remainder is like what you learned back when you were learning fractions and division, is you're going to add the remainder divided by your divisor, which gives you the fraction, right? So this is how, if I wanted to answer my question completely, we always want it in this format: quotient plus remainder divided by divisor. Now in this case, 0 divided by 4x minus 3 is 0, so we don't really have to do it, but again, I'm showing it to you just in case we did have a remainder. Okay, so again, please, if you have any questions, let us know. Okay. All right, so that is long division. As you can see, it could be a little bit long to do. So math comes for our help, or to our help, and it shows us a different way to do also polynomial division, and it's something called synthetic division. So synthetic division, again, is a shortcut for long division, okay? But please keep in mind, in order for me to be able to use synthetic division, my divisor has to be in this form, x minus c. If my divisor has a square or any other exponent other than 1, I won't be able to do synthetic division, okay? All right, so this is a great formula to show you how the process to doing synthetic division. Again, the best way to see all these examples is actually doing it. But let's go through this formula to do synthetic division. Okay, so again, we're going to be giving a polynomial. We always want to make sure that that polynomial has each term in the correct placement value. Okay, so that means that it's in descending order based on my degree of my polynomial. Okay, and my divisor always is going to be in this format, x minus k. Okay, so first, if we see that if my k is positive, I'm just going to put k here. If my k is negative, we'll see an x plus here, and that's going to make sure that my k that I'm going to be dividing by is a negative, right? So then we have to identify the coefficients of my polynomial. So in this case, again, my coefficients are a, b, c, and d, and I put them in this format, okay? And I do again a little house, but this one's in a little upside down house, okay, when I'm doing synthetic division. So then the format to do synthetic division is this. You first bring down the a, and then you're going to multiply that times the k. So k times a, and this value will go here. And whatever this answer is, you're going to add it to b. Okay. So we have b plus k plus a. And then I'm going to do it again. I'm going to multiply k to this term and add it to c. Okay. And then I'm going to go again. I'm going to add these two terms, and then I'm going to multiply by k again. And that's going to go here underneath the d. And then I'm going to add the d. And this last circle here, again, because I'm out of terms, will be my remainder, okay? All right, so again, thus r will be my remainder, and what's left over here is the coefficients of the quotient. Now, always keep in mind, when we're doing division, we are simplifying our polynomial. So whatever our degree was that we started with, our dividend, we're going to lose 1 degree on it if it's in this order, right? So just keep that in mind. And again, the best way to see this is with an example. So let's go ahead and look at an example. Let's use synthetic division to divide x squared plus 5x plus 6, and our dividend is going to be x minus 1. Again, we can use synthetic division because our dividend is in this format, x minus 1. So again, what is our value for k? So hopefully we see that if k is positive, it's keeping my formula intact. So the k is going to be a value 1. Okay. Next, I'm going to list my coefficients. Okay. So let's list them. Here, we don't write a 1, but we know there's a 1. The next term has a 5. Then the next term is a 6. Okay. So we're going to go ahead and start with a synthetic division. First thing we need to do is we bring down our 1, and then we multiply. 1 times 1 is 1, and that goes underneath my 5. So now I'm going to add those two terms. 5 plus 1 is 6, and then I'm going to do it again. 1 times 6 is 6, and then I'm going to add these terms together, and I get 12. Okay, so since this was my last term, the 12 is my remainder. Okay, so when I'm going to write my quotient, okay, again, this was my divisor, these were my dividends, my coefficients of my dividends, this is my remainder, and my quotient, if I'm going to write it in this format, quotient plus remainder divided by divisor, again, I had a 1 and 6, but I started with the square, so that means that I reduced this to just a linear x. The 6 becomes a constant, and then the 12 is a remainder, so that's going to go plus 12 over my divisor, which my divisor is x minus 1. Okay, and this is the format that you'll be answering your problems on your homework. Okay, and again, this is an example of synthetic division. And I don't know if you noticed, or hopefully you realize that this is a much shorter way and a quick way to do division, right, of polynomials. So we love synthetic division. So let's do a couple more. Let's practice using synthetic division. And then again, um, um, the the benefits of doing this, again, if I go back to my polynomial here, it's much easier to find my zeros with my divisor, my quotient, and my dividend. Yes. So again, this is the reason why we do this. So let's go ahead and do this next example. Let's use synthetic division to divide this polynomial. 4x cubed plus 3x squared plus 3x minus 32. I love it. It's in the perfect order. It's in descending order. All the terms are in the right place. And they're giving me a divisor that I can use synthetic division. It's in the form of x minus k. Okay. So again, what is my k? My k is a positive 8. Since there's a minus, it didn't change it. So it's a positive 8. Okay. So that's going to go outside my house. Then inside are my coefficients. Let's go ahead and grab them. So it's 4, 36, 36, negative 32. Be careful on those signs. Make sure you place the coefficients with their respective signs. Okay. All right. First step, we bring down the 4. So we bring down the 4, and then we're going to multiply 8 times 4. 8 times 4 is 32. And then I'm going to add 36 plus 32. That's going to be a 68. And then I do the process again. 8 times the 68 is going to give me a 544. I'm going to add 36 to that 544. That's going to give me 580. Then I multiply again. 8 times 580 is going to give me a positive 4,640. And then I subtract now because I have a negative 32. This is going to give me a 4608. Yes, a 4,608. So again, what is this value here? This last one was my remainder, okay? This here, these are the coefficients of my quotient. So again, I started with a cube, so my quotient should start with a square. So we have 4x squared plus 68x. The 580 is my constant. My remainder is a positive, so it's plus 4608 divided by my divisor, which was x minus 8. Yes? Again, if I'm going too fast or you have any questions, please let us know. So let's look at a few of these examples. Let's do this one. We're going to divide this polynomial 3x cubed minus 6x plus 21x squared minus 42. And just by reading it, we should take a stop. What do we see that we need to fix first? Well, our polynomial is not in the right order. It's not in descending order. The terms are not in the right placement value for us to do our division. So that would be our first step. Okay. Our first step is to arrange these in the right order. So in the right order, in descending order, would be the 3x cubed plus the 21x squared minus 6x minus the 42. Now we got to notice something. We do have a divisor that it's in the right format, x minus k, but what do we have here? We have a plus. So for this plus to have changed from a negative to a positive, then that means that my k is a negative 7. So a negative 7 times a negative 1 gives me that positive 7 here. So again, my k is going to be a negative 7. So now let's go ahead and start. Let's go ahead and do our division. Our negative 7 goes outside. Inside is our coefficients. What goes in there are our coefficients. So let's go ahead and put them. We have a 3, 21, minus 6, minus 42. And again, I keep saying this, but please, we only put the coefficients. We only put the numbers. Don't put any variables in here. Then you'll make your life a little complicated. Only put the coefficients. That's what makes synthetic division fun, neat, and awesome. Okay, and quick. All right, let's go ahead and do it. Our first step, bring down that 3. So negative 7 times 3 is a negative 21. That goes there. 21 minus 21 is 0. Negative 7 times 0 is 0. Negative 6 plus 0 is a negative 6. Now, negative 7 times a negative 6 is a positive 42. And a negative 42 plus 42 is 0. We love this. We love when we have a remainder 0. It makes our polynomials perfect factors, right? So we love when we have remainders of zeros. So again, Our quotient, our answer for this one, is going to be 3x squared. Again, we started with a cube, so this 3x squared plus 0x. There was no square term, a linear term here. And then the minus 6 is our constant. So we have 0 divided by x plus 7. Again, we can simplify this just to 3x squared minus 6. Okay. And again, for us to solve the zeros for this, it would be now easier if we want to find our solutions for our polynomial. All right. So let's look at a few more. Let's look at this example. Let's use synthetic division to divide x cubed minus 3x squared plus 6 divided by x minus 5. Uh-oh. This one has it has a correct order. It's in descending order, but what do we notice? We are missing a term. And for us to do division, we have to have a placement value for us. And if not, it's going to ruin our quotient. Our quotient is not going to have the right correct values. So in order for us to, before we do the synthetic division, we have to fill in the terms that are missing in order for us to have the correct placement value when we're dividing by our dividend. Okay, so here, if we see here, we're missing the linear term, the x to the first power. So the way we're going to correct that is by adding 0x. I'm not adding a number, I'm just adding a placement value. Okay, so now we can do synthetic division again. What will be our k value? Our k value should be a positive 5 since it's following our formula. So again, what's going to go in here? Our coefficients. Let's not forget about that 0 we added. So we're going to have 1, -3, 0, and 6. Let's go ahead and start the synthetic division. Let's bring down our 1. 5 times 1 is 5. -3 plus 5 is a positive 2. 5 times 2 is 10. 0 plus 10 is 10. And then 5 times 10 is 60. And, 50, excuse me. And 6 plus 50 is 56. Yes? So again, doesn't make us very happy, but hey, we did synthetic division. We do have a remainder. Our remainder is 56. So our answer that we're going to write for our homework, our quotient is x squared plus 2x. The 10 is a constant, plus 10. And then we have our remainder. Our remainder is 56 divided by our divisor, which is x minus 5. Okay. Again, please ask me any questions you may have. All right. So what about Ms. Chuka, would you like to continue and talk about the remainder theorem? Or I can continue, that's fine. All right, so let's talk about the remainder theorem. So if we're giving a polynomial f of x, which is divided by x minus k, then the remainder is given by this formula. See, if I put my k back into my function, it's going to give me the remainder that I was finding out when I was doing the synthetic division, or my long division. So let's go ahead and practice some of this. Let's use the remainder theorem and synthetic division to find each of these values. So let's start with a f of 1. What that means, I'm gonna, well, first let me do the synthetic division. So just so you can see how this works, okay? So if I do synthetic division for here, I'm saying that 1 is k, okay? And then again, I'm gonna get my polynomial. It's in the right order. Oh no, sorry, I'm missing a term, right? I'm missing the x squared. So I'm going to put a 0x squared minus 7x plus 2. Okay, so let's go ahead and do this. So we have our k is 1, 2, 0, minus 7, 2. When I do my division, my synthetic division, bring down the 2. 1 times 2 is 2. 0 plus 2 is 2. 1 times 2 is 2. Minus 7 plus 2 is a minus 5. 1 times a minus 5 is a minus 5. And 2 minus 5 is a minus 3. This is my remainder. But check it out. If I were to evaluate f of 1 for this polynomial here, I'm going to get this answer. So if I plug in 1 here, 1 cubed is 1. 1 times 2 is 2. 1 times a negative 7 is a negative 7. So 5 minus 7 is, sorry, it's going negative 2. And let's see here. 1 times 2 is 2. So minus 5 and minus 7 is minus 6. I need to write it. Sorry, guys. Let me bring out my pen. Too much math today. Okay, here we go. There it is. I did my work. My work was done. I'm trying to do it in my head. 2 times 1 is 2. The minus 7 is the minus 5. We couldn't spit that out. Then the minus 5 plus 2 gives me the minus 3. All right, so again, using my remainder theorem, okay, I can find out if my polynomial um, has a remainder or not. And again, this is useful if we want to get the zeros of our polynomial, find the zeros. And again, it's harder when we have a remainder, but when we have no remainder, it makes our life really, really easy. All right, so let's do that second example, f of negative 2. Okay? Again, if I do my synthetic division, my k value is negative 2. Again, my polynomial is 2, 0, negative 7, 2. Okay, and I see here that my remainder is 0. Awesome. We love it when we have a 0. But again, if I were to use my theorem that says that if I plug this k value into my polynomial, I'm going to get this remainder, this answer. And again, here it is. So when I plug in negative 2, I'm going to get 0. And again, I do apologize. These should be negative 2. Okay, copy and paste. Forgot to change these 3. Okay, so these should be negative 2. This negative f of negative 2 is going to give me 0. Okay, so this is a great way to use the remainder theorem to see if our polynomial can be factored with our divisor. Okay, so again, I keep talking about this, that it's going to help us solve equations, but let's go ahead and let me show you how it's going to help us solve equations. Okay, so if I say that I have this function 2x cubed minus 7x plus 2, for some of us, it might be complicated to factor it out and FOIL it and find the zeros of a cube polynomial because we really don't have a formula to find the zeros on a cubic, right? It's just factoring, right? So if they tell us that that when x equals negative 2, this is a 0, okay? So what I can do is I can use my synthetic division to show that I have a 0. So again, we have an incomplete polynomial. We're missing the x squared term. So again, that's going to be 0 here. But when I put this on here, 2, 0, minus 7, 2, you see that I have my remainder 0. Well, I know that I have 1, 0 here, minus 2. And since a cubic, remember, we have a possibility of having 3 zeros or 3 solutions for this. And to get those other 2 remaining solutions, we're going to use our quotient here. Our quotient here can be written in this. This is going to be 2x squared minus 4x plus 1. And hey, we have several ways to find zeros when they give us a function like this, right? This is a quadratic. So since it's a quadratic, again, I can factor, I can get the square root property, or I can use a quadratic formula. So again, my go-to way to always solve is factoring. Factoring for me, I love it. It's my simplest way. So I can factor this trinomial into this form, 2x minus 1, which gives me a perfect square. I have 2 more zeros, okay? So again, what do we know about this multiplicity? Since x equals 1/2 is twice, that means that my graph at this point is going to touch my graph. It doesn't cross it, just touches it. But now we have our 3 zeros just with using synthetic division. Our 3 zeros would be negative 2 and a double 1/2. Yeah, so this is how it helps us solve for our polynomials. So again, I wrote my zeros here again, okay? I have 3 zeros. Let's go ahead and do another, let's switch. Let's now go into complex numbers. Again, synthetic division was a great way to help us find the zeros of a polynomial. Now let's look at complex numbers. What is a complex number? Okay, so a complex number is not a hard number. No, we'll explain to, I'll let you know what a complex number is. Okay, so the best way to see this is with this example. If I wanted to solve for x on this equation, x squared plus 1 equals 0. Okay, the first thing that I would do is I would subtract 1 on both sides, and then when I take the square root of both sides, up till now you had been answering your homework that this is not a real solution, so it does not exist. There is no answer. Okay, but now we are going to give an answer to something that has the square root of -1. Square root of -1 is going to produce something that's called an imaginary number. Okay, now before I explain more about this imaginary number, if I were to graph this graph, you see that my graph is not crossing the x-axis. That's why it says that I have no real solutions, because it's not crossing the x-axis. Okay? Also, if I had something like this, a parabola that's pointing downward, it's not, even though it's pointing downward, it got shifted down, so it's not crossing my x-axis. So again, I don't have x-intercepts. So if I were to solve this problem, these two graphs algebraically, my math is going to tell me that I have no real solutions. But what we will have, again, is this concept of an imaginary unit or imaginary number. And what you guys need to know is that the square root of -1 is going to produce this term here, I. I for imaginary. Okay, whenever we have the square root of -1, that's going to produce the I. Now, let's think about this. What if I square the square root of -1? Well, the square with the square root would give me 1. I know you guys like to say it cancels, but it would give me an exponent of 1, but that would give me -1. So this is another useful thing that you should keep in mind. I squared, the square root of an imaginary number, is just going to produce the value -1. Now, let's go into what a complex number is. A complex number is a form that is made out of a real part and an imaginary part. And the standard form to write a complex number is given by this, a plus bi. Okay? So we always write it in this form. Please don't put these backwards, because again, on your homework, it will count them wrong if you don't have it in this format, standard form, real plus imaginary. Okay, so the real part, again, this is the formal definition that your book has. The A is the real part, and the B is the imaginary part. Okay, so we are going to be doing operations with complex numbers. Hopefully, the sum and difference of complex numbers is very, very straightforward. And the way we'll do this is just this format. Real with real, imaginary with imaginary. That's how we are going to, do these operations, the sum and difference. Okay, so let's go ahead and look at some examples. That's the best way to learn, just viewing some examples. So A, we have two complex numbers. I have 3 plus I. Again, 3 is my real part. I have the I, which is my imaginary part. And I'm adding it to a 6 plus 5i. Okay, so the process for doing this first one, again, it's the real plus real, imaginary plus imaginary. Now we wrote it here, right? My real part is the 3 plus 6, and then my imaginary part, I don't have the number here, but there's a 1i here, right? So it's a 1 plus 5i. So it's a 1 plus 5. And when I simplify this, 3 plus 6 is 9. The 1 plus 5 is the 6i, right? So the answer of adding these two complex numbers is 9 plus 6i, okay? Easy stuff, I hope. Okay. All right, let's look at the second one, or a second method, right? To combining like terms. You could have just written them all together, the 3 plus I plus 6 plus 5i, and then just combine like terms. I have a real 3 with a plus 6 that goes first, the 9. I have a imaginary I plus another 5 imaginary i's. So I add those two, are 6 i's. Okay, so these two are two ways of doing it. I like the definition method better because it already puts my answer in standard form, which is real plus imaginary. If I do it this format, I may forget to put the real first or the imaginary first. So, but again, whichever you see best, okay, they all work the same. All right, so let's do using method 1, this next example. 3 minus I minus 2 minus I. So again, it's real plus real and imaginary plus imaginary. So here I'm going to have a subtraction, right? I have 3 minus 2, that goes there. I'm going to add it with a minus 1 plus a minus I, right? So a minus times a minus is going to give me the plus here. So minus 1 plus 1 is that 0I. Okay. Now, the 3 minus 2 is the 1. I would get in a habit of always answering your problems like this, 1 plus 0I, because what you're doing is you're answering the problems in standard form. My real part is 1 and my imaginary part is 0. But if you put just 1 on your homework, it's not counted wrong, okay? It'll mark it right, since the 0 times I is just 0. But it's not going to mark it wrong if you put it like this, 1 plus 0I. And like I said, I like to tell my students to get in the habit of always putting it like this, real plus imaginary. Even though the imaginary part is 0, go ahead and write it just for our practice. Okay. Again, the second method, it's the same way. Combining our like terms, we're going to get a 1 here. Okay. All right. Ooh, let's do this one. I like this one. I like to give this one to my students. Okay. So if I want to do this operation and add these two numbers, you would say to myself, hey, I thought we were studying complex numbers, but I don't see an imaginary I. But it is there, right? Because what do we see here? We see a negative inside the square root, right? And we know that when we have a negative 1, that's going to produce an I. Okay, so we are dealing with a summation of two complex numbers. So our first step that we need to do is to convert this into our complex form. Okay, so again, what you can do is this. Okay, so we have this format, this negative 8, the square root of negative 8. Okay, I can separate this into a product, negative times a positive 8. And the reason why I want to do that is because I know that if I have the square root of negative 1, that's going to give me the I. And the same thing with this negative square root of 56. I want to separate that into a product of negative 1 times 56. Again, because the square root of negative 1 is going to give me that I. All right, so when I do this, okay, I get this, right? I get the well, what I'm doing here is I'm replacing the negative y directly to the formula I squared is equal to negative 1. Again, but when I take the square root of the square, that's going to go up. But again, we're just following a formula. So when I do this, I have this. The I squared, okay, negative 1 is I squared times 8. We have I squared times the 56. Okay? And I can take the I squared out. That's going to give me the I with the square root of 8. And this I squared goes again out. It's going to give me the 56. Now I went ahead and added the real part already. I had a negative 3 plus 5. And the negative 3 plus 5 gives me that positive 2. This is where I'm getting this 2. It's the real part. Okay. So then it just leaves me with this part here. Okay. But please do not leave this answer like this. Your computer or your homework might tell you that you haven't simplified yet. And also, it's not in standard form. Standard form is real plus imaginary. And I have two imaginary parts here. So I need to simplify those square roots. Okay, so I can simplify the 8 by doing 4 times 2. And I can simplify the 56 with the 4 times 14. Okay, so I wanted to do this because I know that the square root of 4 is 2. That would come out, leaving me with inside just the square root of 2. Again, square root of 4 is 2, and will leave me inside with the square root of 14 inside. So we have this 2i plus the square root of 2 minus 2i square root of 14. Okay, so what we want to do is when we're putting the problem on our homework, because it wants it in standard form, we're going to factor out that I here. Okay, so we factor out the I, we're left with 2 square roots of 2 minus 2 square roots of 14. And now it's in standard form. My real part is 2, and my imaginary part is this value here, the 2 square roots of 2 minus 2 square roots of 14. Now, and I want to point out another thing. Okay, in the computer and sometimes on the examples, you're going to see that they're going to move the I to the front of the radical. Okay, and they do that for two reasons. What they want you to do is they don't want you to do a silly mistake like if we put the I at the end, sometimes we'll forget to get outside of our square root or our radicand, and we put the I inside, and that doesn't make sense. The I has to be outside. So in order for us to help us not do that silly mistake, we move the I to the front. And again, we can do this because we have a product, right? 2 times 3 is 6, and 3 times 2 is still 6. It doesn't matter the order we multiply. So again, we do that just to safeguard. We can put the I in the front or I in the back. It's still the same answer. The computer should mark it right. Your homework should be marking it right. Okay. All right. Let's look at another example. Okay. Let's perform this operation. Oh, now we're not adding or subtracting complex numbers. Now what they want us to do is they want us to multiply these two complex numbers. So again, this shouldn't be any different as if we had regular numbers. In order for us to do this multiplication, we have to do FOIL. Okay, so let's go ahead and do that. Let's go ahead and do FOIL, and then we're going to end up simplifying it into our standard complex form. All right, so let's go ahead and do this. So when I do this, I'm going to do FOIL. That's 1 times 8 is 8. 1 times a minus 7i is a minus 7i. That was the first term. Now I have to multiply the second term with the other two terms. So I times 8 is a positive 8i. And then I times a minus 7i is a minus 7i squared. Okay, so I can see that I can combine two like terms. I have the minus 7i plus the 8i, which is going to give me the positive I, but I can replace I squared to what I know what that value is. I squared is equal to a -1. So I'm going to multiply that -1 to that -7. It's going to give me a positive 7. Now I have two real terms. So my like terms are these real numbers, the 8 and 7. So 8 plus 7 is a 15. Again, I'm going to write this in standard form, real plus imaginary. So my answer is going to be 15 plus I. Okay, easy stuff. So this is how we multiply complex numbers. It's just basically doing FOIL and putting our answer. Now, let's look at this one. This one's not FOIL, but again, now we have to multiply just an imaginary number to a standard number that's in complex form. Okay, so for us to do this, we just need to distribute the 17i to these two terms, right? So 17i times 1 is a 17i. 17i times a minus 7i is a negative 119i squared. Oh, but what is I squared? I squared is -1. So I replace the I squared with the -1. So negative 119 times a -1, that's going to give me a positive 119. But please don't write this answer on your homework. It's not in standard form. I have to rearrange the order. The right order is the real plus imaginary. 119 plus 17i. Okay, easy stuff, I hope. Okay. All right, so this is my standard form, real plus imaginary. All right, now let's do division of complex numbers. So let's start with this easy one. It says write the quotient in standard form. Dividing my numerator is a real number, but I'm dividing it with a complex number. Okay, just like in fractions, remember, there's no such thing as division of fractions. In order for us to do division of fractions, we have to multiply by the reciprocal of the denominator in order to get our answer. Well, that's the same case here. In order for us to do this division, there is no such thing as division of complex numbers, but as you saw, we can multiply complex numbers. So we would need to multiply the equivalent of the reciprocal of a fraction to a complex number. And the equivalent opposite of a complex number is called its conjugate. And the conjugate is really easy to acquire. Do you see here my denominator here is the real part is 5 minus 6i. Well, its conjugate, its opposite, would be 5 plus 6i. This is my conjugate. I just have to change the sign. Okay, I don't change the numbers. I don't change the order. I'm just changing the sign. So if this would have been a plus, then this would be a minus. The conjugate would have been a minus. Okay, so once I know that what my conjugate is of my denominator, now I'm going to multiply. Okay, so in order to balance my problem here, whatever I do on the bottom, I have to do to the top. So this is like multiplying by 1. I'm not changing any numbers because 5 plus 6i divided by 5 plus 6i, it's 1, right? So I'm going to multiply 5 plus 6i times my denominator and 5 plus 6i times my numerator. And this is going to give me the format to do the division. Okay, so when I do this, again, I have this 3 times this 5 plus 6i, and then I have this two polynomials that, again, I'm going to do FOIL to do, right? So the numerator is easy. It's just distributing the 3 to the 5. So 3 times 5 is 15. 3 times the 6i is 18i. Again, from FOIL, the bottom's going to give me 25 plus 30i minus 30i minus 36i squared. Let's combine my two terms. I have 30i minus 30i, that's 0. And then I squared is negative 1. So a negative 1 times a negative 36. Here, I did the 30i minus 30i first. And then here I'm talking faster than I'm clicking. So we have the I squared is negative 1. So negative 1 times the negative 36 is going to give me a positive 36. And 25 plus 36 is 61. So what you see here is when we multiply two complex numbers by one of them by its conjugate, we're going to lose the imaginary part. We lost the imaginary part and it gave us just the real part, the 61. But please, do not give this answer on your homework. This answer is not in standard form. Remember, standard form is real plus imaginary. So I'm going to separate it into two fractions. The real part would be 15 divided by 61 plus 18 divided by 61i. This is my imaginary part. And this is the answer that your homework wants. Always in standard form. Real plus imaginary. Okay. All right. So let's do this problem. Again, this one is just simplifying. We're not doing operations. We're just simplifying. And the problem says write the complex number in standard form. Okay. So one of the ways to do this is, again, first thing we want to do is we want to separate the negative 1 out so we can get our I. So the negative 75 is the same thing as the square root of negative 1 times 75 plus negative 1 times a positive 12. That gives me the negative 12. Okay. Now, again, negative 1 squared is a negative 1 can be replaced by I squared. Okay. And the square root of a square is 1, or I move it out of my radical, right? So it's I times the square root of 75 plus I square root of 12. But we need to simplify. So the 75, I know that I can move that as a product of 25 times 3. And the 12 can be multiplied times 4 times 3. Okay. And again, I want to get these factors that I know that I can simplify out, because the square root of 25, I know that is 5. I know that the square root of 4 is 2. So that's what's going to come out of my radical, right? The 25, the square root of 25 is going to be the 5, but I have that I outside, so that's 5i. And all I'm left with is the square root of 3 plus the square root of 4 is 2. Take that out, multiply that times my I, that gives me 2i, and that leaves me with a square root of 3. So now I have an addition of two like terms. Both of these share that square root of 3. Think of that square root of 3 as the x. How do I add these, the outside? Well, it's just I add them, right? 5i plus 2i is 7i square roots of 3. So I simplified this term into its standard form. Now, again, if you answer this on the homework, it should mark it right. But again, I always tell my students to write it like this. Real plus imaginary. There was no real part, but my imaginary part is the 7i square root of 3. Okay? All right. So let's look at this problem. Okay? Now that we know about imaginary numbers, you're saying, hey, we've done this already. We know how to solve quadratics. But let's go ahead and see an example of why imaginary numbers are helpful and useful. So if I have this x squared minus 2x plus 2, and I'm not going to use factoring, I'm going to go ahead and use the quadratic equation to solve this. Okay, my a is 1, my b is negative 2, and my c is 2. Okay, if I use my formula to solve for this problem, okay, you're going to see something here. I have 2 plus or minus the square root of negative 4 over 2. And again, in the previous homeworks for chapter 1, you would answer this problem as they don't have any x-intercepts. The graph is not crossing the x-axis. There's no x-intercepts, DNE, right? But now we no longer can answer that. So now that we know that we can evaluate a negative square root, we're going to do this, okay? So for this answer, okay, again, just as before, I'm going to separate that -4 into a product, -1 times 4. Why do I want to do this? Because I know that -1 is the same thing as I squared, and I squared to a square root is just going to come out of my radical, so it's going to give me the I, okay? And then the square root of 4. Now I can do the square root of 4. Square root of 4 is 2, right? So then I have this. I have 2 plus 2i. Now what I can do is I can factor out the numerator, or just go ahead and separate it and they'll factor out each other. Okay, so since I have a common denominator, I'm going to separate it into two fractions. 2 over 2 plus or minus 2 or 2i over 2. Again, 2 divided by 2 is 1. And 2 divided by 2 is 1, giving me the I. So again, this solution has imaginary solutions. This quadratic doesn't have real solutions, but now it has imaginary solutions. It has two of them. Again, it has a 1 plus I and a 1 minus I. Okay. Again, and you'll be seeing this. Okay. Now, any questions? Now, I have about 8 minutes. Let me do something really quick that these were kind of simple to do, but I want to point something out. Let me go back to something like this. Like, for instance, the square root of 75. Okay, let me get my pen out. The square root of 75. Let's say that you didn't know that 25 times 3 gives you 75. So what I would do is I would do a factor tree for the 75. So 5 is a prime number, right? Or 75 is a multiple of 5, which is a prime number. So that's what I would divide this number by 5, okay? So when I divide 5 into 75, that gives me 25. Okay, now 5 is my prime number, 25 is a composite number, so I would divide this number again by 5, and 25 divided by 5 is 5, yes? So you see here that the square root of 25 can be written as a product of these leaves. 1, 2, 3 would be 5 times 5, 2, 3 would be 5 times 5 times 5. Okay, and again, square roots, since there's a 2 here, it's all about making pairs of numbers. So a 5 comes out, okay, and then which leaves you with your square root, right? But again, this is just an example on if you have other terms one way, if you don't see the products. Okay, so again, thank you all for joining me today. If you I'll pass it on now to our coordinators. Okay, thank you all and have a good weekend.
Wow, thank you so much, Mr. Carrizales, and to all the presenters, Mr. Isasi and Ms. Yuka, for presenting today. Remember the next week in Math 13-14 we have finite zeros, of polynomial functions, and Math 13-24 we have the exam to review. For academic success, topic is like test anxiety with the Student Support Services Program, like SSP. And thank you to the audience for coming. We hope to see you again soon. We learned a lot in this presentation. Thank you for everything, and have a good weekend. Please, if you have questions, we're here in the chat that you can ask questions. There are many tutors that can help you in your questions, and thank you everyone.